Okay, so with you guys, Ihor from Jelastic.
Thank you. And Bruno, you know probably Bruno because Bruno is one of the most famous people in Java world. He is from Brazil, and actually he is very good person. And personally, I learned a lot from him. And I'm super glad that Bruno, you are together with me today. So let's talk. So we will have a conversation today. So it's not it's not a speech, it's just a conversation. So we want to share our experience. We would like you to share your experience. We just want to talk with you. So let's start. Today we will talk about the problem.
Yeah, okay.
It's
right.
It's okay.
Not working?
Oh, it's almost.
Okay, so let me all right, so yeah, so today so one of the main things that we have, let me ask you, who here has downtime problems? I mean,
actually
everyone has downtime problems, right? Actually, so that's the wrong question. Who here has problem of downtime when you have to update your application? I mean, that you have to turn servers down, you kind of keep some time, servers disconnected. Who has those kind of problems? Just a few people? No one else have problems with that? Okay, come on. It's like I don't put applications up, right? So that I don't have problems with downtime, right? You know, a lot of times we have this. There's two different kinds of downtime, right? One is the downtime that happens for things that you don't control, right? So, for example, you're running your application. There's a bug, right? So your server crashes, right? So it's something that maybe you failed somewhere in your test or something like this. And that's a problem. Of course it's a problem. Then you have to run to get your application back up and everything. Now, or sometimes your server provider just kind of have problems and it gets offline, or your network disappears. There's lots of different things. Their application can become, oops, man, oh God. I'm not sure if you realize what just happened. The guy tried to open the window. There's lots of glasses right in front of the window, right? So that would be a cool stuff, all those glasses falling on the ground. So that would be downtime, right? For glass at least. Now, there's another type of downtime. There is the downtime that happens because of we decided to happen, right? That when you upgrade the application, you're going to say, okay, we're going to upgrade the application, and we shut things down to upgrade the application or to change the database or to do something, and then, now we are the cause of the downtime, right? And so this is really bad because, it's totally preventable in a way, because we could have think in a different way. We could not disconnect the server, right? So, but downtime, there happens a lot of times. It happens for, can you just pass it real quick? Yes, a lot of time it happens because we need to increase our application somehow, right? So, for example, if you do have to do some hardware maintenance, right? So sometimes even if you're doing a virtual machine or in the cloud, I'm not sure how many you have, like, for example, your machines on Amazon. And from time to time, Amazon sends you a message saying, your machine, it's going to be disconnected, so you have until that day to restart it or something like this. So you have to restart the machine before Amazon stops it. Or sometimes, your server kind of grows, and you need a larger machine. What happens if you need a larger machine in Amazon? Well, you have to shut the machine down, increase the size, and then start it up again, right? So all of these kind of falls on the hardware maintenance thing. You have to improve your system underneath, right?
And not only from a perspective of end user that use actually hosting services, but only from a perspective of hosting service provider. If you need to do any upgrade, anything, you need to disappoint your end user, and your users are unhappy. So that's
if you have any hosting provider, a lot of times your hosting provider says your machine is going to be up for maintenance at some time, and then it's going to be offline from that time to that time. And I'm sure, has anyone has gotten this email from providers, right? It always happens. Yes. All right. So wait, come on. I'm in the previous slide. Where are you going?
Oh, sorry. Yeah, right. we still have problem.
Yes. Right. There's other things. All right. Okay. So so sometimes you have a cluster, and then there's some machine in your cluster is like more heavily used for some reason, and then you have to kind of you want to move things around, run another cluster, so you have to do, and then you kind of shut, or maybe you want to you have several machines in the cluster and you want to shut down one of them or put another machine in the cluster. All of these are kind of downtime. Sometimes your user doesn't see it, but it's downtime that you have to think. One interesting thing that we do is that a lot of times we do planned downtime, right? That's this kind of things, you say, I have my bank account in a bank in Brazil. I'm not going to name banks, but I have my bank account in a bank in Brazil, and for some reason, from 2 o'clock in the morning to like 4 o'clock in the morning, you can't do anything, right? You can't do any transactions, and that's okay. You're usually sleeping about that time, but when you're traveling, and sometimes you're like early in the morning here, and you try to do some transaction before you come to the event, like just happened a couple of days ago, right? And then the bank is offline because they're doing some kind of planned downtime, right? And I think this happens a lot. A lot of times we want to upgrade our application, so we plan the downtime. And there was a speaker in this room here earlier today. I'm not sure, I didn't catch his whole talk, but I don't remember his name. But he was talking about doing deploys of applications in production during business hours. Right? A lot of people do deployments of applications off hours, right? And he was explaining why it's very good to do during business hours because everyone is there, the whole team is there, if anything happens, right? And yes, it's much better to do deploy of applications during business hours. Why don't we do it? Why do we do in weekends at nights, right? Because we have planned downtime, right? So we're going to do upgrades or any deployments you do during the nights or during off hours, because that's planned downtime. So anything happens, the users are not going to see. The problem with the network, with the internet today, is that any time is a time that users are online, right? So so a lot of times we have to kind of think about this downtime problem.
Yeah, so dev guys are also disappointed because they have to do night hours.
Yes.
They don't have choice. So that's like that's a workaround, ugly workaround to do the things.
Yeah, exactly. A lot of times we say, oh, we're going to do maintenance, so let's just plan the downtime. The user's not going to complain, but that's just a workaround. We want no downtime, right? That's the best thing. Okay.
So let's watch through the solutions, what we can actually think about if we want to do no downtime.
Yeah. So
Actually.
So a few things that we do is that we just kind of do reroute things, right? You have like a load balance in the front, and then you start different servers in the back end, and then if you're going to stop something, you stop sending requests to one server and move to another server. So that's a good way of doing things, right? You can just reroute your traffic, and then people are not going to see the downtime because it's actually not that machine is not responding to any request. So that's a good way.
But the bad thing about this that people requires actually time and hardware. So you need spare hardware to spin up new virtual machines, new containers. You need time to do this, and you need to be sure that your data is consistent with the one that is going to be down. So that's actually requires some extra efforts, which is actually not a perfect solution. That's why.
Yeah, the other way of doing these things, like there's a lot of talk lately today about microservices, and a lot of people are talking. You can re-architect your application with lots of different components, and so so instead of having any kind of downtime, you just kind of shut down one component, restart a component. Edson Yanaga was talking the other day in one of the events that we did this week. So we've been traveling all over Europe for the last 2 weeks. So Edson Yanaga was talking the other day about you having like this service that kind of cache some requests. So if a microservice goes down, you can cache a request, so the user doesn't notice that anything went down or anything downtime. So microservices are also a good way of kind of mitigating some of these downtime problems, right?
But it requires actually people to be knowledgeable about that, and actually it requires architecture to be planned from the very beginning in the correct way. So as you know, microservices is a very young direction. So people were writing the code for ages, but they were writing the code for ages in a way they used to write it, and this approach will completely not work for legacy story. So any big legacy application is not a microservice. So it's not easy just to split it with a knife and say it can be just spinned up particularly from other parts. So this thing will also work only for some certain applications. That will not work for everything. So if you have data center, you have thousands of customers, you won't ask anyone, so do you have microservice? And you, maybe you, or you? I didn't,
All right.
for example. So it's an issue. So
yeah, so basically, the whole idea of microservices is very good, but of course it requires, a lot of people have problems deploying one application without downtime, right? And then you do say, okay, so we're going to do microservice so we can prevent downtime, and then instead of deploying one application, you're deploying maybe 10 or 20 or maybe 100 microservices, and then you're now having to make sure that all of those 100 microservices don't have downtime. So, it's already hard enough to do with one, right? So, moving to microservices just because it's not necessarily the best way to do it, right? So, because it adds a lot of more complexity. You have to really think the application. And sometimes you don't even have the time to actually rethink your application, so you don't have downtime, right?
Right. So now we're gonna be a bit dreamers.
Yeah. So let's imagine that instead of all of these, let's imagine that we could do a very cool thing. That is, let's imagine that we could migrate our application from one server to another server without stopping the application at any point, without stop sending requests to it. Let's imagine that we could actually do this kind of things even between data centers, like kind of get an application that's running on Microsoft Azure and move it to AWS, to Amazon, for example. And we're just going to reroute all the users transparently. We don't need to care about any of those things. We're just going to do this, right? So that would be really cool, right? So let's imagine that we could do this. How would we change our development if we could actually migrate applications from one server to the next without stopping the requests, without stopping the word, without any kind of downtime, right? Let's see what kind of things we could do. First of all, hardware maintenance is going to be a lot easier, right? Because, if your hardware has problems, right, or it's too small, you just start a new VM, right, or new hardware. It could be like a real physical machine, and you just migrate your application to the other guy, and you shut down the previous one, right? So, no, it wouldn't be a big deal. If I could just kind of migrate without problems, I could just do this, and that's easy, right? So, it's a lot easier to do hardware maintenance than or upgrading the hardware or anything like that. If I could just do this live migration thing.
Then rebalancing. So another thing, if you have your applications scalable and you can scale vertically, so the size, amount of RAM which is consumed by the application can grow dynamically, or amount of CPU consumed can grow dynamically. The issue is that you have static servers and you cannot actually grow dynamically too much, because you have another applications running there and you will have unbalanced cluster. Some of nodes will be underloaded and another nodes will be overloaded. So because it's impossible without downtime to migrate the applications which eat at too much RAM. So that's also would be an issue. And if we could migrate it on fly, that wouldn't be an issue. We could keep the cluster be equally load balanced. So only if you have big application here, some small applications can drive to another node. And so that would be cool.
Yeah. So that's an easy way for us to actually resolve the problem of unbalanced servers, because you're just going to migrate. Think about if you have lots of microservices, for example. If I could, some of the smaller microservices could just move them out to a new server, that would make a lot easier for us to balance our servers back again. Right, and what would you do if we had this thing? If we could just migrate things, then the whole DevOps pipeline would change. So that's how we do today, right? Since we basically we have our definition of our container, right, somewhere in Docker Hub on the Hub registry, for example, and then we're gonna do development. So we start the container on our development environment and add all the data to it and everything, so we can develop and everything. Now when we move to test, so when we move to test, we download again the container and we run, we configure our test environment and everything, so we run our tests, right? So then when we need to do staging, we do the same thing. We download from the registry the container, right? The image of the container, and then we add the data, we run all the staging thing, right? If you're gonna do production, the same thing. Oh, come on, don't.
Sorry.
Right, the same thing. We kind of always download and reconfigure the container in each one of the environments, right? Now, if we had, if you could just migrate applications from one server to the other without any kind of downtime, right?
Yeah.
Come on, you have to, now is the time to pass the slide.
I just thought about another case. So imagine, sorry for interruption, imagine that this container is sick and it's memory leaking, and you need to analyze this container. I can download another one, I can spin another one, but I cannot take a look into the issue right here because that is on production, and I need to move it to a special isolated place where my engineers could take a look and to find the problem. And actually, that is also the issue. You can spin another one, but you cannot dig into existing one because that is production.
Right.
And yeah, as for pipelines.
Yes. Okay. So yeah. So then you know, if we could actually just migrate the containers, right, or migrate your application, right? You know, so we could just kind of start the container on the development environment, and we can run all the stuff there, make the configuration that we need and everything. Okay. So is it good? Right? So I can migrate it to test, let it run all the test stuff and everything. And then when it's ready to do staging, I can just move to stage, and then so the guys at staging, because then the test doesn't have access to that application anymore. Just the guys at staging have access to the application. Now they can configure everything they need for staging to say, okay, so now it's ready for production, right? So now when you're gonna move it to, it's the same binary, right? So you're just gonna move it to production, and so now we can clone one and move to production, or and move it to another production. So now it moves into production with all the configuration the right way. Everything, you know it's the same binary, you know it's the same thing that's working, the same configuration that's working is the same IP address that was working on stage, for example. You know, if we could just migrate things, then this thing is going to be turn the whole production deployment a lot easier.
Yeah, because time would be saved. You did not to provision. You did not need to provision it directly on production. So the place where container is provisioned with your application can be absolutely different from the place where your application will be running at the end. So, for example, imagine that is my build system, and I actually build my containers right here. So I can deliver this from this place around the world. So absolutely everywhere. My container will be delivered up and running, and I don't need to waste time to reconfigure everything, to start to build anything in a new place. So everything is up and running and can be just be delivered to production on the fly.
Right, and then when he's talking about all over the world, what does that mean all over the world, right? You know, so let's see, you know, can you, let's say if you had multiple clouds, right? You know, not every cloud provider is in every country, but you know, if you have a set of cloud providers, you can actually reach all kinds of different things. So you know, maybe we could move, right? If we had this thing called live migration, we could just move our application from, you know, Amazon to Azure, for example. You know, so maybe Azure has all kinds of data centers around the world. Amazon also has. They're not exactly in the same place, so maybe you could benefit from having your application running different things. Or maybe you could have things like that. You could have your development environments running on Amazon, right? So you could do all the tests and everything, but you know, your production environments, you actually have, I don't know, you have a deal with Microsoft, or you have a special requirement for your customer, then you could just actually migrate your applications to run in production in a different data center, right? We've been, as I said, we've been traveling all over Europe. One of the problems that a lot of people mention about using cloud computing in Germany, for example, is that Germany has all those laws that certain types of application can only run in a data center inside Germany. I'm sure in Brazil we also have the same things. You know, healthcare applications, for example, or financial application can only run in data centers inside the country. And so sometimes you say, I want to run on Amazon, but if Amazon doesn't have a data center in your country, then you can't run. But you could do all your development on Amazon and then run production in a data center in your country if you wanted to, if you could just migrate applications from one to the other without any problem, right? Or you could have a customer that says, you know, I'm already have my environment running on certain cloud provider. Can you just run the application here? You could do all those kind of things.
Yeah, it's all about moving workloads. For example, you recently opened another region in another part of the world, and you also have actually connected your data center here, or not your data center, maybe it can be public cloud, or again, it can be Azure, it can be Amazon, and I need to move all my workloads to this place because this place requires more my attention than other places. So that's a kind of business decision to move your workloads more flexibly. Then another thing is competitors. So if you have multiple clouds connected to your system which can distribute your containers on fly, you can actually take a look to the prices. So if suddenly, for example, tomorrow morning, Amazon will be for free, for example, maybe, I will move half of my resources to Amazon because it's for free. And if suddenly, again, in a day after that, Amazon become 2 times more expensive and Azure will be 2 times less expensive, you can be flexible with this. So you can move your workloads due to actually dynamic things like prices, or another thing. So data center can be down, for example.
Right.
News, Amazon burnt out.
It happens, yes.
It happens, why not? So you need to be flexible. You need to be flexible and not to lose your data and your application.
So yeah, so a lot of times you think, oh, that's kind of weird. Would that really happen? You know, we recently we had a problem in Brazil that, you know, some of you might have heard all the confusions and political problems that we have going on in Brazil right now. So one of the things that happened is that the dollar conversion kind of went way up. All right, and so when he did this, hosting things on Amazon in the US, because Amazon only charged in dollars, got a lot more expensive than if we just hosted things on Microsoft Azure that charged in reals in Brazil. So, you know, so a lot of times there's all kinds of different things that you can do to use these things.
And now we can show our focus.
Right. So, you know, and then another interesting thing about multiple providers is that, for example, we had in Germany, we had these guys that they're running all of their development, all of their testing, all on Amazon, because it's, you know, it's faster, it's all cloud and everything. But when they go into production, production has to be inside their customer, because their customer is not running production in anyone's other data center. They're not running their own data center. So now they have to do all the testing. And so when it goes to production, that's when they have to recreate the containers, redo everything, because now it's a completely different data center, right? And so everything you tested before is kind of different now that you're going to run in production, because, you know, you have to restart the whole process.
And do you think that is all possible?
So now, you know, if that would be a good way, so can we show how we do this?
Yeah, it wouldn't be fair if we just said, but if we didn't show there actually how that can work.
No, there's one more slide. No, come on.
Oh, just a second.
Yes, there's one more slide. Before you do the demo, let me. Yes, okay, yes. So now,
that one.
Think about it. If we're going to do live migration, right? How would we do live migration? You know, is this something reasonable to do, right? You know, this is a reasonable way of doing live migration, right? We can, at some point, you know, we're going to get. So we have the source node right here, right? That's where our application is running. We want to run in the destination node upstairs, right? So we're going to get, at some point, we're going to start copying, right, everything that we have from the source from the origin, right, the source node to the destination node. So we're going to copy everything. We're going to copy the binaries, we're going to copy the data, and we're going to copy the memory, right? So we copy everything. This can take some time. It doesn't matter because all the requests are being answered by this guy here in the bottom, right? So that's not a problem. We can just kind of keep copying those things. Now, once we have copied enough, right, and we can start syncing, right, the difference between what's going on in this guy here, what's going on in the other guy, right? Syncing difference in memory, different in disk, everything. We can do this, right? It doesn't look so complex. But at some point, we gotta stop, right? Because if you keep access requests down here, things are gonna change. You're not gonna be able to move up, right? So at some point, you have to freeze this state here, copy the rest of the stuff that's missing, and then unfreeze the application on the other side. right?
Here's a problem. So
That's a problem.
Yeah, because many years before that wasn't possible, because actually the key point number one, your connection. So you already have server is connected to a client, and this client like interrupted. Or another thing, the data which you was working on from this source node need to be exactly the same on the destination node. So the user could even not see the disconnect or the issue. So these issues, all of these issues been solved already. So there is a technology called CREO. It's checkpoint restore in user space that allows to freeze the process in different to usual virtual machine where everything is packed to a RAM image and then packed on the destination node. That thing operates by process. So it collects all the data related to each process and unfreeze, pack this process and unpack this process on a destination node together with all the settings, with all the TCP settings that were, with all the TCP connections that were established on the source node. So
I mean, so you're saying that we have the technology today that we can freeze memory, processing, data, networking, everything,
absolutely.
and just kind of do the last step.
The story of this technology wasn't so simple because they were trying many times to put this technology to a core of a Linux kernel, but for many reasons this was declined. So that's why some of things were moved to user space, but the technology itself works for now, and some improvements to Linux kernel being done to make this happen, to make this technology work. For example, TCP repair mode, so it's ability to restore your TCP connection, which is already established, to another node with all the settings that were previously set on that node, and to continue your connection without any issues as it was before. So
okay, so I mean, can we when you say it's working, can we actually see this working?
Let's try.
All right. Okay. So let's try. Okay.
So
we're going to show you here how those concepts can apply. I mean, we're going to show how live migration can work, right? And one interesting thing is that we're going to show here on the Jelastic platform, right? Because live migration is a reality today. You can do this. There's some vendors that already provide. So the more we start thinking about that this is possible, the more we can rethink the way we do things, because those things are possible. So we're going to show here in Jelastic, and then we're going to talk about who already provides this for you. So
as you can see, the node is now located on Amazon.
Okay, so first of all, I'm not sure how many of you guys know. So Jelastic is a container orchestration platform.
Right.
So it's used to orchestrate. It's like the cranes, when you go to the docks and you see all the cranes managing the containers, right? So that's this for software containers, right? So Jelastic is the platform that manages all the containers and makes sure that all the containers work well, right? So and what you're seeing here, this is the developer view of Jelastic. So you also have a operations view that we're not showing here right now. And so here you're going to see all of the, each one of these lines here is actually an environment that's composed of several components. I mean,
it's a set of containers. So your application is, for example, one environment. It's a set of containers. And for now, we have a platform connected to hybrid clouds. So there are many of clouds connected together. It's also Amazon, Azure, SoftLayer, so there are many of them connected together. And we have Minecraft server running on Amazon right now.
We're going to do Minecraft?
Minecraft.
So Minecraft is cool, right?
Yeah, so I will show you.
All right, so basically what he's going to show here, right, is that, we have all the servers right there. I mean, you have the environment. Minecraft Live Migration is one environment with lots of different containers inside, right? So so you might have database containers, you might have application server containers, you might have your messaging application. All of these are like separated in different containers, and so you have the full environment there, up and running with everything that you need to run your application, right?
Yeah. So as you can see, there is a connection string with my endpoint that is following to this container. Minecraft is running, the private port which is listening, And
Okay.
my actually Minecraft application, I will show you. I created it today because actually we didn't actually first expect it to show it, but then we decided why not. So as you can see, demo multi-cloud, it's Jay on the beach show. So we connect to it.
Okay, so we're
And
now. So,
Bruno, can you play Minecraft? Because I cannot. Actually,
okay,
I'm not a Minecraft expert, so it's
Come on,
loading.
who's a Minecraft expert here that wants to play Minecraft while we do this?
Are there anyone?
Come on, come
oh,
play
please.
Come here, play Minecraft
Yeah,
with us.
really,
Come
because
on, come on.
I can't
Okay,
even mine any
come on.
resources. Please.
Put your hands together. Come on, yes.
Really.
Right.
Honestly, I've been playing this for hundreds of times, but I don't know how because actually, so you see,
All right.
there is something going on.
Okay,
So you can-
so he's gonna start playing Minecraft, right? So what we're doing here is we're running Minecraft.
It's night, so we can wait
Yes.
for a minute or two. That will be.
So wait, do you start the migration already?
No, not yet.
no, okay.
So you are still on Amazon. So
Yes.
we're playing Minecraft in Amazon.
So he's running the Minecraft
Actually, who
client.
has Minecraft client on the phone? We can give a URL. You can connect it. We will be playing together.
Yeah, so we could all, that's a server on Amazon. You could all connect to the Minecraft server. We should start.
Do you have on a phone?
I'm not here
no,
right
I
now,
don't
but
have
yes.
it either.
My phone is not in the network,
I'm not a
unfortunately. so-
Minecraft user, so it's a real Minecraft.
Come on. Who wants to connect to the server? Does anyone want to connect to the server? Can you give the URL? No? Okay, right.
Okay,
so
no
we
problem.
should think about this next time.
Yeah,
All right. So he's going to be running, and he's going to do anything he wants there. It's kind of dark, unfortunately, but you know.
Yeah.
But you can see this right there, right? Can you see it?
Can you see
Can you
it?
write a light somewhere? Oh, he can see better than we do. Okay. All right. So he's going to be playing. So we have a Minecraft client connect to the Minecraft server on Amazon, right?
Oh, sorry.
So, come on.
It's
come
a
on.
flying mode.
It's dark. It's night.
how-
No, you're not supposed to be playing. No, no. Let him
okay.
play. You're supposed to be here. Okay.
Yeah,
let him
I'm
play.
here. I'm here.
All right.
I cannot play Minecraft.
Huh?
I cannot do this. So
Yes.
I tried to play, but it cannot.
Okay. So he's doing it now.
Okay.
Why he's doing it? Can we start the migration?
Yeah, now we can.
Okay, so-
let me interrupt you just for some seconds. I will start the migration.
So the
we will-
migration will take some time because he has to copy all the containers, all the data, everything from Amazon to Azure, right?
So we
We're
will
gonna
migrate to Azure. Yeah, right.
Oh, we're not going to do to Azure. We're going to do to. So basically, what he's doing here. Look. Okay, I couldn't even see.
So we
right?
started.
He just click a button and
Please.
say, "I want to migrate this to
So you
another
can
provider."
play.
Right? Okay, so now.
Migration is in progress.
Yes.
So
So now it's going. There is a update.
yeah, that is here.
Yes. You see it right there. That's kind of dark. Like.
Yeah.
Okay?
On the backstage, it is written that it's migrating. So we will see notification right there after the server will be delivered to Azure. So now it's progress to Azure.
Yeah. So now the servers are moving from one provider to the next provider, right? It's going to be Azure this time. You did right, Azure, right?
That's Azure.
Yeah. So it's moving from right here. You can see here migrating.
Oh, yeah.
From so it's kind of spinning right there. Why are we doing this? The user doesn't, the interesting thing about doing live migration is that it might take some time, right? To copy the data, copy everything, but that doesn't matter, right? Because you don't have to tell the user stop using the application because we're going to migrate, right? So it's just going, right? So it might take some time. Not sure how long it takes here, but it's a couple of minutes.
So what should we do in the game? So we should mine
Yes,
something.
what do you want to
yeah?
do in the game, right? Why we do this? Come on, what do you want him to do in the game, right? Create
It's done.
explosions?
Let's
Okay.
do it again. Let's try again.
Demo mode.
Demo effect.
mode, right?
Demo effect. The issue actually can be internet connection, but
No,
let's
no.
try again. I want to try again. Okay, is it okay to try again?
Can we try
Okay.
again? Can we try again?
Perfect.
All right.
So let's connect.
Demo mode, right? He said, we shouldn't do this live, right? But I said, we got to do this live because we have to show that this works, right? Okay. Just gonna try again?
Yeah, we'll try again. I'm
Right,
not sure about
right now.
Yeah, right now. I'm not sure how internet connection is, if it is good, but let's try.
Okay, so the internet connection not working?
I don't know. It's trying
I
to
think it is. It's
connect.
streaming from there. So.
Okay.
All right, just gonna. Okay, so basically, the whole idea is that this has to be very stable, right? This kind of thing can happen, of course, right? So we are in a demo, the demo mode here.
Okay.
There's lots of things
Let's
that our
try
servers
again.
are kind of need to be adjusted to be like real stable every time. But the cool thing is that we're doing this every day, right? We're doing this right now. But so, for example, on Tools Cloud, that's the company that we run. We're doing this kind of things every day. We're moving containers from one server to the next. We move the containers from Amazon to Microsoft Azure, right? So once you have everything like set and running, okay. So
yeah, it's already going again.
Okay, so it's already going, and we start again.
We are moving
right?
back to Amazon.
We're moving back to Amazon, right? Okay.
Yeah, prices are getting better there, so we move to Amazon.
Yeah, all right. So prices. Okay. So now let's see if that's going to happen this time. So basically, the funny thing is that once you start doing this kind of things, right? We do this every day, right? A lot of times we have this one application that we have some people using, and I use this on my demos. When I do live migration demos, I use it on my server, and I just switch back and forth this application. So it does work, but of course something was wrong on our configuration in the back end. We may have made a mistake, right?
Maybe, but that should work. So actually, the key point is not to actually worry about new technology. So you should
success. It's already migrated.
Whoa!
All right. Okay. Keep playing, man. Keep
playing. Yeah.
Yes. All right.
We did it.
All right. So basically, the user, we migrated the server from one cloud provider to the next cloud provider. Oh.
Yeah, but that's not an issue of migration, so it's most likely issue of a connection. Migration was done before that.
Yes,
so migration was done before that. So I will, yeah. So it's probably it is related to but anyway.
It's demo mode, right? But
we can try again.
Thanks very much. Right?
Thank you.
No, we're not gonna try again.
Thank you.
Thanks, man.
Thank you.
Thanks a lot. Okay. Anyway.
So
10 minutes. All right. Okay, guys. So basically, once this thing works, right? Okay, get back to the slides.
Yeah.
Okay. At least the migration finished, and then there's some networking problem, something. But so that's basically what happened, right? We kind of move things. Then at some point, there's just a tiny little bit of state that we kind of do to migrate from one side to the next. There's very little change on the application itself, right? But of course, the Minecraft client helps in some ways, because the Minecraft clients, keeps connecting to the server all the time. Sometimes, some applications don't work totally, especially when you have a client, right? But if you're doing like web application, for example, that the browser connects, for example, it's very easy. So it's easy for some applications, harder for others. Minecraft is a good example because it's a client that does connect to the server, right? So it's like one of the hardest examples that we can do, right? Most times when you do, for example, when you do web applications, that basically what you're doing is just guarantee that the cookie is the same and that the encryption is the same, everything. It's a lot easier because, the next request goes to the new server. So that depends on the kind of application, but mostly works without you doing anything in your application at all.
It works very nice with streaming application if you're trying to stream movie, because you have buffer, which is actually the part of data which is buffered, and it's actually very seamless for the end user. But there can be some bottlenecks and things we need to also talk about, because
a few things you can't do, right? For example, if you have like a big data application, or you have a huge amount of data that changes very frequently, you don't have time to actually stop in one place and start in the other one. So it's not for every type of application, but for most of them.
The freeze time can be bigger than you expect. So usual freeze time can be from 5 seconds to 30 seconds for big applications. But in case if you have very frequently data that is changing all the time, it's hard to actually move everything to accept this data, and this delta that will be part of this data will be transmitted far more longer than you expect. So that's why your application should actually think about timeouts for your connection. So actually for web browser and the usual web applications are not an issue at all. It's mostly related to some real-time applications that requires actually even no delays in the network.
Right.
So Another thing is data integrity. So it's important to make sure that all the data you have access from your application on this point, on the source point, you have the same access to the data, to the same data on a destination point. Usually within containers that is supported by file system, which can live, for example, in an image. So when you transmit the image will be will be actually consistent. Yeah.
Okay. So now,
yeah.
Next one. So one interesting thing is that once you have that, other things we're talking about, migrating inside the same data center. So we're doing here migration between data centers, but of course, if you're doing this between two servers in the same data center, it's a lot easier and a lot faster. So you can do much more real-time applications because the network it's a lot faster than moving across data centers. Come on, what are you doing? Okay. Anyway, right? And so but the interesting thing is that once you start being able to do across data centers from multiple vendors, that's when the multi-cloud thing starts getting interesting.
There are some secrets. So it's you will say how that can we work on multi-cloud as networks are completely different. So that's an Amazon network, that is Microsoft network. So there is another technology which is growing right now. It's overlay networks, SDN, software management networks, and we have good partners are here in Telemant who are working with SDN, so they're doing their own SDN solution. That is very nice, and the same thing, very similar to this, we are using, but it's actually not automated in the same way as guys has. So that's overlay network. So network on top of another network. And we do use this to connect clouds between themselves. So inside, it's a single network.
Yeah, no, it's because we don't have time.
Sorry.
Right. So, with multi-cloud, you don't have lock-in with vendors.
Yeah.
Come on, next. We don't have, we can do hybrid cloud. You can do, your own private cloud, and you can burst things to a cloud provider, or use the cloud provider as a disaster recover guy, for example. High availability disaster recover. You have a lot less risk if you're being able to span multiple cloud providers.
Yes.
So now, one interesting things here.
It's all about bottlenecks, so we know about this.
Mm-hmm. So there are some. We talk a little bit about this, right?
Yeah, we talk about this. So
yes.
One more thing we didn't mention that about external IP addresses. So if you don't have any cast IP addresses, you should also use single entry point for your request. So there should be a gateway server, which actually will handle this overlay network between the clouds. So this is clear, because if your client application was talking to the server that was an Amazon, and the entry point was on Amazon, it would be hard to convince him that now his entry point is on Azure, in absolutely another IP address. So, but it's not an issue if you actually build your own overlay network. So that is a solution for this. Okay.
So yeah, just because we don't run out of time. So now one interesting thing is that there is, come on, show everything. So I mean, there are some containers right now. There are provide live migration. So live migration is something so Jelastic provides since 2011 live migration. Docker is working on it to provide live migration. But there's other there's all kinds of technologies that are doing this. One interesting thing is that live migration for containers is going to happen, right? So the sooner you can start thinking about what you can do, how your applications, how your data centers, how your environment can benefit from this, because it's a reality today, right? We're doing this daily on our environments, running on top of Jelastic, but other providers will allow this soon. So it's a nice way for you to think about how you're going to actually solve all the downtime problems with this. Okay.
Yeah, so as you can see, Run C already had this. Docker will gonna have this very soon, because everything is developed right now. So you can see many demos with the migration of Doom and everything else. So keep using new technologies. Okay, so if you want to do this in your environments, talk with the guys from Jelastic, because you can actually do this today. You don't need to wait for other things. And I'm not sure if you can have like a one time for one question or something.
Okay, thanks, guys. Thanks a lot.
Thank you. Thank you.
Okay, do we have one time for one question? Questions? Comments? No, the demo didn't work. That's a good comment.
Well, this is only applied really to containers, really, because if you have the services attached to your provider like RDS or the cache or the balancers, this is only applied to containers. You need to have those databases inside containers for yourself or clusterize your persistence, because when you migrate containers from one service to another, you lose that kind of connectivity and that kind of security environments and stuff like that. How do you handle that kind of situation? This is only really for stateless containers and applications?
Oh, no. So containers in Jelastic are not stateless. They are very stateful. So we're talking about state here all the time, and we're talking about data because the data is inside the container. So the thing is, we're moving today, I'm not sure, I think maybe we should have started with this, but we're moving today to a world where everything we're going to be doing is more and more in containers, right? So that's like the, a lot of people are doing this today, but more and more people are going to do. Docker containers are stateless, right? But even then, you can still have data containers, for example. And yes, the idea is to move everything. You move the data, move the state, really move even the state in the memory, right? So we're not talking about just kind of replicate the binary of the container, just start a new container there. We're actually moving the memory of one container, the state that is in memory from one container to the same container running another provider with the same state in memory. Right? So even if you have an in-memory database running in one container, when you move that in-memory database to another container, that's going to work because we're replicating the memory also, right? So yes, it's stateful containers.
Yeah, and it's in real world, many applications are really stateful, and it's hard to make them stateless. For example, game servers, some kind of legacy search servers, so they're stateful by design, and it's hard to make them stateless, especially if it's legacy applications.
Yes, one of the cool things is that once you can handle stateful containers, you can handle a lot of the legacy applications, because a lot of the problems that people are having with containers today is that now they have to rethink their applications to run on the stateless containers kind of thing, and your application was not thought that way. But actually, if you're using stateful containers, like that's the case that Jelastic uses stateful containers, then you don't need to change anything in your application. It just runs on the new platform. And they are all containers. Yeah, so all the pieces are different containers, and then you can migrate the whole thing. Okay? All right, thanks guys.